Hello students, we are in 8-5. We are going to be talking about distance. We'll start off with the launch problem. Remember, just try your very hardest and then I will show you the answer in a second.
A park worker gets a call from her boss who says, build a rectangular sandbox with your 20 feet of board. Put a corner at 0, 0, 0, 5, 4, 0, and the phone goes dead. Show how the worker can plot the sandbox on the grid without calling her boss back. Tell why she has more than enough board.
If you plot the points, you can easily find the missing corner. You can read this answer to see what a possible solution could have been for you. Part 1 Intro.
There are some measurements, such as temperature, where negative numbers have meaning. There are other measurements where negative numbers are meaningless. Distance is an example of a measurement that is always non-negative. Recall that absolute value measures the distance a number is from 0 on a number line. Absolute value is never negative. Distance cannot be measured in negative units.
In this example, we want to find the distance between x and y. So we would find x, we would find y. I noticed that my y-axis is not counting by ones. It doesn't go 1, 2, 3, 4. It counts by 2. So 2, 4, 6, 8. So to find the distance, I can just count up. 2, 4, 6. So example A, what is the distance between point X and Y? The answer would be 6 units. When I'm trying to find B, what is the distance between point Y and Z? You notice that my Z goes down into the negatives. However, what the intro just told us is negative numbers don't really matter for us right now when we're dealing with distance. You can't travel a negative distance. What I can do though is plot my points on a coordinate grid, just like I have here, and then count the spaces or the lines between my numbers. So if I'm at -2 and I go to 0, I'm finding the absolute value of -2. So it goes 2, 4, 6, 8. What I did was I added my absolute value of -2 and I also added 6. So 6 plus the absolute value of -2 will give me 8, meaning the distance between point Y and Z is 8. Moving on to my got it problem, I have drawn a coordinate plane over here to help me.
What is the distance between the points 4, 2 and 4, -2?
You can plot the points on the graph to try and figure it out, and then your answer choices are below. So if I was graphing this, I would move to 4, 2, and I would plot a point. I would move to 4, -2, and plot a point. And then what I have to do is count my spaces. So I go from -2 to -1 to 0 to 1 and 2. So all together this is 1, 2, 3, 4. So in this situation, my answer is D, 4. Moving on to part 2.
Your cousin rides the subway to work. His trip is shown on the coordinate plane. Each grid line represents one block. Part A. What is the distance between the start and Station 1? Part B. What is the distance between Station 1 and the end?
I would love for you to try this on your own first, and then we will talk about it in just 1 second. A is asking us to find the distance between start and Station 1. We cannot show distance as a negative number, so you will notice that we're starting at 10 on the grid, and we're moving down to 6. We can find the distance by subtracting 10 minus 6, or we can count our grid lines. So 1, 2, 3, 4. The distance between the start and station 1 is 4 blocks. It says then, what is the distance between station 1 and the end? What we could do, since we have some negative numbers and some positive numbers, mathematically, we can say we want the absolute value of our end, which is -4, and we want to add it to where station 1 is, which is at 6. The absolute value of -4 is 4, and then we add 6, and that gives us 10. That's how we can solve it mathematically. We can also use this picture and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The answer to B is 10 blocks. If you aren't drawing out a picture mathematically, remember, if one is negative and one is positive, you're adding the absolute values. If they both are positive numbers, then you're subtracting them to find the distance. Part 2 got a problem.
What is the distance between the points -3, 2, and 2, 2?
The correct answer is that they are 5 units away from each other. You could draw a picture and plot the points. The other thing that you could do is mathematically notice that we're finding distance between the x-axis because our y-coordinates are the same. So I know that I'm going to be using -3, and I'm also going to be using 2. Since one is negative, one is positive, I'm going to be adding the absolute value. This equals 3 plus 2, which gives us 5. Moving on to part 3.
A city planner is using a coordinate plane to plan a new city park. The 4 corners of a rectangular dog park will be located at A, -3, 1, B, -3, 8, C, 5, 8, and D, 5, 1. What is the area of the dog park?
What we need to do in order to find the area of the dog park is to first plot our points. A is at -3, 1. B is at -3, 8. C is at 5, 8. And D is at 5, 1. From here, what you have to do is you have to count the distance, or what we can do is add our absolute values to find out the side length of this segment and the side length of this segment, because area is length times width. So if we have the absolute value of -3, which is 3, and 5, I know that the distance between this point and this point is going to be 8. Or I could count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. I then need to count up this way. 1, 2, 3, 4, 5, 6, 7. Or we could do 8 minus 1. Then we multiply. 8 times 7 is 56. The answer to our question, what is the area of the dog park? The area of our dog park is 56 units squared. And here's our last got it problem.
A right triangle has its vertices at -3, 4, -3, 7, and 5, 4. What is the area of the triangle? Use the formula A equals 1/2 times B times H, where B is the base of the triangle and H is the height.
This one's a little bit more tricky. Here's your options. The correct answer is B, 12 units squared. This is how we get the answer of 12 units squared. We know A equals 1/2 base times height. So the length of the base is absolute value of -3 plus 5. So from here all the way over here, we talked about how you can add our absolute values, or if you drew out the picture, you could count 1, 2, 3, 4, 5, 6, 7, 8. The height of the triangle would be right here. 1, 2, 3, or what they did was 7 minus 4 because they were in the same quadrant. Then you have to apply those numbers into our equation. So A equals 1/2 times B times H, base times height. So 1/2 times 8 times 3. If you multiplied all of these together, you would get the answer of 12. That's all I have for you for this lesson, and this is actually the last lesson that we're going to do for topic 8. So make sure that you have filled out those booklets that I've given you. Make sure that you're asking questions, and make sure that you're working hard in class to accomplish those homework assignments so that we can get this all figured out before we take our test, which is coming up in a couple days. See you later.